Good afternoon, everybody, and welcome. Hi, I'm Cheryl Reynolds, and I'm with the UC statewide IPM program. Welcome to the UC Ag Expert Talk today on gibberellic acid use on avocado to improve fruit set. Peter Casina is also here, is going to be running our polls and troubleshooting any technical problems. And please note that today's topic is mainly targeted to commercial growers and pest management professionals. The materials used in a commercial application require a permit. And we want to say a special thank you to the Citrus Research Board for their support of this webinar series. Okay, so at this point, I would like to introduce our speaker today. Dr. Ben Faber is here today, and he is the Soils, Water, and Subtropical Advisor for Ventura and Santa Barbara counties. And today he's speaking on gibberellic acid use on avocado. So Ben, I'm gonna pass this over and you can go ahead and share your slides.
Here we go. This is a combined presentation material that I put together along with what Carol Lovett, biologist at UC Riverside. The topic is use of the plant growth regulator gibberellic acid 3 to increase avocado fruit set and yield. And so this is application of an material to a plant in order to increase fruit set and potentially yield. And this is based on 6 years of work that Carol Lovett did. And the point I'd like to make here is that we're applying a material to try and enhance yield, try and increase the number of fruit set on flowers and ultimately make a whole lot of fruit. But the overriding factor in avocado, and this is true for agriculture in general, is that weather is the overriding. It is the key factor. Is it hot? Is it cold? Is it wet? You know, this is what ultimately decides a crop that is harvested. And what you may be able to set a lot of crop, but you know, in the past years we've had heat spells that have occurred in the spring and in the summer, and a lot of fruit drop results. So just getting fruit set is not going to tell you exactly what you're going to harvest at the end of the year. Avocados are on the tree for at least 9 months and as long as 18 months. So between fruit set and harvest, a lot of things can happen. So I'd like to cover a little background about hormones. So we're talking about gibberellic acid, which is a hormone. And these are plant stimulants that are generated by the plant itself. A hormone is, you know, in living things. Hormones have been found in bacteria as well. But a hormone is a Greek word that says, that is defined as to set in motion. It's a trigger. It sets off a set of processes that are in the plant. And this is opposed to a nutrient, which is usually taken up by the plant through the roots or through the leaves or something like that. So this is a hormone, is something that is generated by the plant itself. And when we're talking about hormones in plants, we're talking about phytohormones. And again, these are hormones that are generated within the cell. When we apply them, when we use an application of a hormone, we call these plant growth regulators, or PGRs. And these can be either synthetically derived or extracted naturally. The gibberellic acid that we use are actually a fermentation product. These are materials that are applied to plants, and in commercial applications, these are registered for use and a permit is required for their use. There's a larger group of materials, biostimulants and bioregulators, that are also substances and organisms that are applied to stimulate plant processes. And these may not be naturally occurring. For example, hydrocyanate is used to make deciduous plants appear to have gone through chilling requirement. There's also other materials that, such as the systemic acquired resistance materials like the phosphonates or the salicylic jasminoic acid pathways that improve a plant's ability to resist pathogens. And these, in turn, have an effect on the hormones within a plant. Okay, these can be applied externally as you would a PGR, since they are PGRs actually, but they're not naturally occurring. So, for example, the phosphorus acid materials are a not naturally occurring material, but they act as if they were a hormone. And then we get into this really complicated sphere of the plant chemical communications. These are actually hormones that are generated by plants that can actually signal to insects and other plants about pests or attract beneficials. And this is getting to be a really interesting area of hormone investigation. But that's way beyond the discussion in this seminar. So hormones. The first hormones actually were identified by Egyptians and Chinese. Ethylene, which is, there's 5 major groups of hormones: ethylene, the GAs, auxins, cytokinins, and abscisic acid. You know, the Egyptians and Chinese saw that smoke, which contains ethylene, can actually accelerate the ripening of, in the case of Egyptians, figs, and in the case of Chinese, pears. The wildfires that we have around here, we've seen the effect of smoke from wildfires accelerating the ripening of cherimoyas. You know, so smoke can have a very strong effect on ripening, and that's the ethylene. Ethylene is naturally occurring. If you want your avocados to ripen faster, throw a banana in there, which generates a lot of ethylene, and the avocados will ripen better. GAs were identified in the 1920s in Japan because they found that certain plants, rice plants, grew differently, and they identified this hormone, GA1, as affecting plant growth. Auxins have been around for a long time. Again, identified in the 1920s. We've heard of indole acetic acid and indole butyric acid and naphthalene acetic acid. Turns out the materials here that have the asterisk, like NAA, naphthalene acetic acid, GA3, and ethylene, are all actually registered for use in avocado. Cytokinins have been identified as increasing cell division. Abscisic acid has been identified in inhibiting growth. Excision is leaf crop and fruit crop is. So all plants have got these 5 hormones in them, and they come in different concentrations and different ratios. They all affect some aspect of plant growth. Some of the more important ones are dormancy and germination, flowering, stress tolerance, but they all, and we can use these as PGRs, applied hormones to improve plant performance. So, you know, about root tone, the rooting hormone that improves rooting of cuttings. So there's been a lot of commercial applications of hormones over the years. So many of these PGRs are naturally occurring, some like uniconazole and paclobutrazole, which are used in other countries for controlling tree size and improving fruit set in avocados, are not naturally occurring, and even though they are PGRs, they're not registered in this country for use in avocados because they are not naturally occurring, and they potentially can increase. They don't decompose over time and can pose environmental hazards. So GA3 it's a naturally occurring, again, hormone in plants. It's produced commercially through fermentation, big vats, just like beer, and it's extracted the way alcohol would be from a fermentation. It stimulates cell division and elongation, we know that. It breaks seed dormancy. It increases seed germination. And so it's doing a lot of things in a plant. So it's not just our goal, which is to improve fruit set. It's doing a lot of other things in a plant. It increases fruit size in grapes and reduces seediness in mandarins. So it's been used commercially for a long time for a lot of different reasons. So, you know, when you go to the grocery store and you buy these grapes that are the size of plums, it's because Ga3 has been applied to them. So there are many, many different types of gibberellic acid, and they're labeled 1 through 130. And Gib was the first one, Gib 2 was the second one, Gib 3 was the third one, Gib 130 was the last one that was found. So that's how the labeling comes around. And this looks complicated, but as a molecule, it's one of the more simple hormones. Not all of the gibberellic acids are bioactive. So the only commercial one that is used as the PGR that's sold as a stimulant is Ga3. So PGRs in various concentrations, combinations, and ratios have got significant effects if they happen at the right time and in the right conditions. So that this really needs to be underscored clearly, that weather is the overriding factor, and you have to have a healthy plant, and you have to have all factors. You have to have the bees flying, everything, for fruit set to occur and for a PGR, for in this case Ga3, to actually have a significant effect. Hormones can have radically different effects at higher and lower concentrations. So, for example, many of the herbicides are hormones that are highly concentrated, and they work because they accelerate plant growth, cell division, and elongation to the point that they die. And so you got to watch out for how you use hormones, because at the wrong concentration, you can get the exactly opposite effect of what you desire. So the temperatures have to be right for plant growth, for flowering. The conditions have to be right for the pollinators to be flying, and the trees need to be healthy. And if you don't have these conditions, you know, just applying a gibberellic acid or hormone is not going to work. So all the conditions have to be lined up for a hormone to work. If it's too hot, if it's too cold, you may not get any effect, or you may get an undesirable effect. So fruit set, things need to happen in the right order and conditions. Much of this is timed by hormones itself. So there's a suite of things that happen. And I think at this point, there's a set of questions to be asked. So phytohormones are answer A, B, or C. Phytohormones are major structural components of cells, transient, initiating different processes in cells, clearly described, defined, and understood. There should be one correct answer out of those three. Right on, it's the transient. Hormones are not persistent in a plant. They are transient. They are sequential in their appearance, and so they sort of initiate one after another. They are not major structural components of cells, and we don't know a lot about hormones. We're still learning. That's the point I was trying to make about how we're finding out that the hormones are involved in communication between other plants, and it's not just cell to cell. So yeah, it's on to the next question. So B is the right answer. Phytohormones applied as PGRs are only naturally occurring, are interactive, are capable of overcoming weather conditions. One of those is the right answer, A, B, or C. Okay, they're interactive. And phytohormones are, for the You know, that's a bad question, actually, because they are naturally occurring. They're naturally occurring and they are interactive. Yes, A and B are the correct answers. So that's a bad question. So let's move on. So for fruit set, things need to happen in the right order and in the right conditions. And much of this order is timed by hormones. So there's several things that have to go on before fruit set occurs. You have to have pollination, and pollination is movement of pollen from the male flower to the female flower, from the stamen to the pistil. And then you have what is called pollen tube growth. This is the pollen actually will grow down through the pistil to arrive at the ovule to fertilize and create an egg. And that is called fertilization. So pollination and fertilization are two distinct processes. Fertilization is the pollen tube coming into contact with the ovule. So there's a period during which the pollen has to grow down to the ovule and contact in order to start to grow. Then you need the egg to grow. And so that is what is going to become the seed. And it's not really clear at this point how gibberellic acid affects any of these processes. We know that it does, but we don't know exactly how it does it. But we do know that conditions need to be right for this to happen. You have to have sun. A lot of the pollinators don't fly unless there's sun. We're finding out now that sometimes there are nighttime pollinators of avocados, but the temperature needs to be right. If it's too hot or too cold, the pollinators will not be flying. And the tree and the flower have to be in the right condition. So it's not just movement of the pollen and creating fertilization. You have to have other things that are set for this all to happen. So here's the old flower. Okay, and the avocado flower is what's called a complete flower. It has both male, it has stamens, and female parts, the pistil. So this is the pollen is generated here, and it's moved to the tip of the pistil, and it will grow down to where the ovule is. Okay, and here is the female flower with the stamens open or spread out. And here's the male stage where the stamens are upright, and this is the stage at which they release their pollen. So the thing about the avocado is that this is an artificially created image right here. Avocado flowers are either in a female stage or a male stage. So you don't normally find male and female like you see here, open at the same time. And that's why you need the bee to do pollination. Or actually in the case of avocado, this is the old world insect, the honeybee, and the avocado is the new world plant. And there's actually a lot of things like hoverflies that are doing the pollination. And houseflies will do pollination as well. So there's a lot of native bees that will do this as well. So you have to have pollination, movement of the pollen from the stamens right here to the pistil. And then the pollen grows down, the pollen tube grows down the pistil to the ovule to get fertilization. And this actually takes about 48 hours for that pollen tube to grow. And it's got to be above 50 degrees. So at nighttime, if the temperatures drop below 50, in that 48-hour period, the pollen tube will not reach the ovule. So daytime temperature 75, nighttime drops to 40 or 38, you're not going to get fertilization. Okay, so temperatures have to be right. So here we go. This is the presentation that Carol Lovitz. Oh, do we have a set of questions at this point?
Yeah, I think we do. So I think there's a couple questions right now.
Okay, pollination and fertilization are distinct events, true or false? You've got a 50% chance of getting it right. All right, let's go on to the next one. Yes, They are distinct events, and if the conditions have to be right for both for fruit set to occur. Next. Avocado flowers, and this is to choose the best answer, are complete with both male and female parts in the same flower. B, need a pollinator, only set a small proportion as fruit, or all of the above. So A, B, or C are correct, or all of the above are correct. There's actually over 1 million flowers on an avocado tree, and you're lucky if you get 100 pieces of fruit off one tree.
And we do have a question that came in while they're answering this one. What role do the staminode and inner stamen play? Do they produce any pollen?
You know, they actually produce nectar, which is, that's, flowers can be male, female, or hermaphrodite, and the staminodes actually are attractive because they have a little bit of nectar, but they're not part of the female portion. So it's a weird flower. It's, we talk about synchronous dichogamy. It opens as a female, closes, then opens as a male. And if you go out and you look at the avocado flower, you'll often find it's in the female stage day after day, and then it might close and then open as a male, or it may seem like it opens briefly as a female and then is open as a male for 3 days in a row. So it hasn't read the textbook about how it's supposed to flower. It's a crazy breeding. It's really designed for outcrossing as much as possible.
Are they now? Okay.
Yes, they are now. So yes, all of the above. So avocado flowers need a pollinator. They are complete with both male and female parts, and they only set a small portion as fruit. So D, all of the above is correct. So yeah, it's a crazy breeding system. So here we go. Carol Levitt put this talk together, and it's how to use Ga3 in order to increase fruit set and yield. So increasing avocado yield and profit. So this is all part of making money. Plant growth regulators are the most powerful tools we have for increasing fruit size and yield in existing orchards to increase fruit profit, grower profit. And it was only last year, on March 27th, 2018, that GIV was approved for use on avocados to increase fruit size and yield. So we've only been commercially playing with this, although Carol worked on it for 6 years. ProGib LV Plus is the material manufactured by Valent Biosciences, and it's the only Ga3 registered for use in avocado, and this is under a special local needs permit. The reason for that is this is a low volatile organic compound, so it minimizes off-site drip. And the reason for this is that, again, this is a hormone that can have significant effect on plant growth, and you don't want an aerial application. So, most avocados are going to be using this as an aerial application. You don't want this floating onto your lemons and causing some problems. There have been problems with the use of biostimulants moving off-site and causing problems with other crops. So this is the main reason why the ProGib LV Plus is the only one that's registered for use. ProGib and generic Ga3 products cannot be used. ProGib LV Plus has the advantages that the restricted entry interval is only 4 hours, so you spray it and you can go in and check your irrigation lines. The pre-harvest interval is 0 days, so that, see, this has always been an issue with avocados. Should I pick, should I not pick? I've got 2 crops going, da, 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 da. Anyway, so when you're applying this in the springtime, you usually have last year's crop or this year's crop, if you want to call it that, on the tree. So you've got the flowers that are there that you want to affect, and you've got the crop that you're going to harvest in whenever your packing house tells you. So anyway, you can apply this and harvest the crop that's on the tree. And it can be used in certified organic orchard. Again, it's a naturally occurring material, therefore it can be used in organic orchards. Okay, here is where things get kind of tricky. ProGib is applied as a foliar, actually a floral spray, but we're applying it to the canopy of a tree. It's a floral spray being applied to this cauliflower stage. Okay, the cauliflower stage down here. It's just prior to flower opening. Okay, and and avocados are not really synchronous in their flowering, coming all together. It's applied when 50% of the trees in a block are in that cauliflower stage. So 25% of the bloom will be in an earlier stage, 25% will be approaching bloom. So so this gets kind of difficult because you're at the top of a tree on the north side, the east side, the west side. The tree's going to be in different stages, or you're at the top of the hill or the bottom of the hill. So you got to make some sort of a, judgment about, what the overall orchard is in. If you are unable to make the application at this time, it's better to be a little bit late than early. Okay, so if a lot of the flowers are open, that's better than if they're all closed. But applications done at full bloom are less effective. So, this weather influence, the long bloom period of avocados adds to the difficulty of identifying the best time to apply. And this is why it took 6 years for Carol to identify this as really a beneficial use. So timing can be difficult because of the different stages of trees on the north side of the slope, the top of the slope, bottom of the slope, whether you're on the east side and so on. So all these trees are going to be in different stages, and you got to make some kind of a judgment of, it's time to go. Plus, then you need to avoid unusual weather. You can't apply it when, the bees aren't flying. If it's too cold, if the pollinator's not working, you're not going to get pollination, and if it's too cold for pollen to growth, you're not going to get fertilization. And early sprays may be too cold for fertilization to occur. So at this time, we're not really sure exactly how GA works or how long it works. It's not clear how long the Gib effect is, whether in a normal prolonged bloom, multiple sprays would be effective or safe. We know that in coastal lemons, late season sprays can cause phytotoxicity. But the bloom pattern of avocados might indicate that it might be good to do 2 sprays, but the permit only allows for 1 application. So you got to make your best judgment. And you've got to have trees in good condition. So this is the ideal stage right here for application. And if you can't do it, it's all right to have some of the trees in bloom, in full bloom. Okay, so here is the timeline for a tree. We're in this period of March, things are starting to bloom. We get fruit set, we get a very rapid fruit growth, which slows down. And then we come into next year's bloom, and so you can apply this material at this time with fruit on the tree, and you don't have to wait for harvest. So you've got fruit on the tree, you can make the application and harvest the next day for that matter. So we're looking ideally at, just after bud break at this cauliflower stage in full bloom. So if you're going to make a mistake, if you're going to err, and you definitely are going to make a mistake, it's better to be slightly at full bloom than at, when the trees are just opening up. And right now, March 18th, things are pretty much in that stage where it would be good to make an application. ProGib Plus is applied as a whole tree, whole canopy application. Oh, I don't know why that does that. To the developing inflorescences, you do not spray to runoff. The permit only requires only allows for 12.5 fluid ounces of ProGib LV Plus, which is 25 grams of active ingredient in 100 gallons of water. This is can be, you can go up to 250 gallons with the Ag Commissioner's permission. So in Ventura County, they are allowing 250 gallons for ground application. For the aerial application, it's 75 gallons with the 12.5 fluid ounces. And that's the maximum, one application of this material. And this is the right amount. Again, we're dealing with hormones. If you go to lower rate or a higher rate, it's quite likely to be less effective. And here's the classic plant growth regulator response curve. And this is what you see with indole acetic acid. So in the case of roots, if you put on too much, you'll see an inhibition of growth. If you put on the buds, if you put on too much, you'll see an inhibition of growth. You'll see as you increase the amount of applied material, you'll see an inhibition of growth. So the dosage doesn't seem to be as sensitive with Ga3 as it does with indole acetic acid, though. The final pH of the material should be about 5.5 to 6. The Ga3 should not be exposed to pHs of higher than 8.5 because it breaks down. It really helps to add a wetting agent, organosilicone surfactant like Silwet, that helps as a spreader so it gets into all parts of the flower. In Carroll's research, they use 200 to 250 gallons as a ground application. And again, this, depending on the Ag Commissioner, is permitted. The labeled rate is for 100 gallons though. So if you can't get your Ag Commissioner to allow the 250, this is the registered permitted rate is 100 gallons. The aerial application is for 75 gallons. Okay, so these are the results that over a 6-year period that Carroll got for comparing Ga3 treated trees versus control. Sheesh, the Ga3 produced a minimum of 22 pounds increase. And this is for trees that were yielding between 44 and 373 pounds as control trees. So this is a minimum, so it was almost a 50% increase with the trees that were only producing 44 pounds. If you're looking at 110 trees per acre, you're looking at, about 2,500 pounds increase per acre. That's a minimum. And they were looking at orchards that were producing between about 5,000 pounds to 40,000 pounds per acre. So an orchard that had 3,300 pounds had a 50% increase, or 1,800 pounds. So, this is a small amount of material. I'm not sure exactly what Ga3 costs at this point, but you're talking about under $300 an acre for application of the materials. And so you can have a significant increase in yield with a for a small cost. This is the other important thing. In all cases, the yield of commercially valuable fruit increased in parallel with the total yield. So this is important because in a lot of orchard trees, as you increase yield, increase the amount of fruit, increase the number of fruit, often the fruit size decreases. In this work in avocados, it did not change the proportion of valuable fruit. 54% of the average increases were as by weight per tree and also as a net number of valuable fruit in the 60, 48, and 40 sizes. And the number of fruit increased by 61%, as well as that number and proportion in the valuable fruit size. Now, this chart represents an average of 20 years of all avocado trials that Carol Levitt and did. And the trials that she did over the 6-year period were very similar to the gibberellic trials, gibberellic acid trial. In most fruit crops, there's a decrease in fruit size as the yield increases. So here is what happens in avocados. So these gray blue boxes or columns show increase in yield. And as the increase in yield goes up, okay, these open circles represent the fruit size. And so there's fruit size doesn't seem to change very much as yield increases. And so this was true with the Ga3 trials. Even though the yields were increased, the commercially valuable fruit did not diminish. So in summary, the Ga3 increased yield by a minimum of 30 pounds per tree. So that's about 60 pieces of fruit. It did not seem to impact both on and off crop yields, years. So the yields were over a 2-year period, averaged over a 2-year period of on and off crop yield years. It didn't diminish the yields. It did reduce pre-harvest fruit drop on the fruit that was on the trees. It increased fruit size on the trees, on the fruit that were sprayed. It delayed fruit blackening with no effect on ripening on the fruit that was on the tree. On the setting crop, it increased yield, fruit size, it stimulated leaf growth, which protected the fruit from sunburn. So here is a summary of all that work that Carol Levitt has done. It's available online and it should be available as a link that Peter can put up in the chat room. At this point, Ga3 applications are under a special local needs registration, which means only one application and no more than 25 grams of active ingredient. So that's 12.5 ounces of the Pro-Gibberellic plus. More work certainly needs to be done. See if rates and application frequencies are more compatible with different flowering and weathering patterns. So the work that Carol has done so far is identified the ideal time for one application. So in the future, it may be determined that other application frequencies and timings might be just as satisfactory. Also at different stages. So in summary, yield improvements are only seen on healthy orchards, and Ga3 is not going to resurrect poor trees and actually could make them worse by adding stress. So at this point, there's another set of questions. GA3 application timing is, you have a choice, by the calendar, B, by size of the tree, C, by stage of the flower. One of those is correct.
And we have some questions coming in, and so I'll ask you one at this time. So the first question here is, not being a grower, are bees brought into avocado groves for pollination as with almonds?
Yeah, so honeybees are a managed pollinator. We know how to use them. Honeybees hate avocados though. They'd rather go to just about any other flower. But it's kind of insurance. Yes, you will find honeybees pollinating avocado trees. And in many cases, it's doing service to the beekeepers because they're brought into avocado orchards, which are up against foothills that have a lot of good pollen and nectar that rejuvenate the bees after they've been in the almonds. So there's a lot of other pollinators that are working avocados, but honeybees are the only ones that we know how to really manage. So that's why they're brought in. Yes, all right, GA3 application timing is by the stage of the flower. I'm glad that idea got across. Dose response to most PGRs is the more applied, the better. True or false? If 1x does well, 10x is going to really give me a good shot. True or false?
And then another question about the gallons per acre. So if applied aerially, isn't 75 gallons per acre a lot? And then a follow-up to that was, how can the Ag Commissioner approve more gallons per acre than that's on the SLN?
Okay, the SLN is for 75 gallons by air, and 75 is fixed. And actually, if you see the dusting that a helicopter does on an orchard, that's a good application rate. By ground, it can be increased to 250 gallons, and that's what the work was done with. I don't know why the SLN says 100 gallons, but I'm sure the Ag Commissioners will permit it, as they have in Ventura. When you're doing ground applications, it's hard to get good coverage. So that's why the 250 should probably be used. Right, dose response for most PGRs is do it at the right rate, man. If you put on too much or too little, you're gonna get something that you don't expect. So it's false, correct. The spray solution must be pH adjusted, contain a wetting agent, be no more than 25 grams active ingredient per acre, or all of the above. Choose the best answer.
And then another question for you. Do growers in Mexico or Chile use this product?
Everything that we do in California is done somewhere else in the United States. Carol Lovett, her work has worldwide implications. Now, the thing is, it's a cheap material to use. And most of the avocado growing world uses one of the growth retardants, the paclobutyrazoles, the sunnies, the uniconozoles, to affect fruit set. And I'm sure they're going to use whatever they can get their hands on to improve profitability. There were several growers from Michoacan through here several months ago. I know they were using Gib. So, and I'm sure they're experimenting with it more so than we are, since we have to follow the regulations here. Anyway, spray solution. Okay, all of the above. All of it. It's got to be. It's got to be around pH 6. it needs to contain a wetting agent. It works better, well, it doesn't need, but it works better with the silhouette, organosilicone wetting agent. And you can't use more than 25 grams of active ingredient per acre. So all of the above. I mean, that's the thing about these hormones. Everything has to be just right for it to work. And the weather is the overriding factor. What kind of yield might be expected from a Ga3 application over an unsprayed orchard? None, a decrease in yield, a 50% increase, or A and C?
And while they're answering that one, here's one. Did Carol observe much difference in effectiveness between the aerial and ground applications?
Only ground applications were made in order to obtain the SLN. So the aerial application rates are extrapolations from what was done on the ground. I know many growers did a lot of aerial applications last spring, and it was not the best time to do it. You know, we didn't get the registration out until the middle of, or the end of March, and so the applications, a lot of them were going on. It was really too late to see an effect. I know people claiming that they saw effect, but unfortunately, most of those growers did whole orchard applications. Whenever you're introducing a new material, you want to only do a portion of an orchard in order to verify that it's actually doing something in your orchard. And this is something most growers don't do. So you can do an internal evaluation of a product that way. You know, at least leave a corner that you don't do. Okay, A and C. So you either are going to see no effect, or you're going to see a potentially a 50% increase. So it's either on or off. And it's all dependent on the timing of that application to whether everything is just right. So D was the right answer. How many times are trees allowed to be sprayed per year according to the SLN? 1 time, 2 times, 3 times? Yeah, 1 time. That's it. According to the SLN, 1 time. At what point of flower opening are effects most likely to be found? At 25% cauliflower, 50% cauliflower, or full bloom? A, B, or C? 25% cauliflower, 50% cauliflower, or full bloom? 50% cauliflower stage, that's the ideal. And it's hard to achieve an ideal in an avocado orchard. You know, if you've got 1 tree, yeah, you can figure that out pretty easily. But if you've got trees on a slope, especially if you've got different age trees, different size trees, it's a hard guess. So it's better to err slightly on the full bloom if you're going to make a mistake. But if you're doing a 25% cauliflower, we know that that is not going to have maximum effect. So 50% cauliflower is the right answer.
Just a couple announcements before we go back to questions. The next webinar will be on April 8th with Dr. Beth Grafton-Cardwell, and she'll be speaking on Citricola scale, and you can register for that today. It will be open. And as always, if you need additional CEUs, we have our online courses. You can see the URL down there at the bottom. So at this time, while people are filling out their surveys, I'm going to go ahead and go through these questions. Okay, Ben, you have some time to hang around?
Oh, you bet.
All right. Okay, so does this product work on different varieties of avocado?
You know, this was all done on Hass avocado, and there's enough similarity that it would probably work on other varieties. The question was, does it work by the calendar? Does it work by the tree size, or by the flower? So you just follow, you're looking for that 50% collar stage for it to have its effect. And, you know, I presume the concentration, you know, ideally be something else than because it's used on HASS. You know, in the ballpark, GA3 is not as sensitive as other hormones, so I expect some sloppiness in its use and its ability to get an effect.
There's another one. So can we assume that GA3 enables each tree to hold more of its fruit set through to harvest, irrespective of the fruit size increase?
You know, I would, that's what, that's why it's used in lemons. And the work Carol did shows with less fruit crop, right? And that you don't see blacking as soon on a tree. So it fruit in a more brittle state, you know, it doesn't age as rapidly. And that's why gibberellic acid is used. So yeah, it's going to hang on longer.
Does it change fruit flavor?
Ha! The longer avocado hangs on the tree, the more oil it accumulates. So yeah, it will. I mean, because of the GA3. Remember, GA3, gibberellic acid is naturally occurring. That's why it's authorized to be used on orchards. So if fruit hangs longer, the flavor is going to change.
Can you apply micronutrients with pro-gib application? And what if rain is forecast? Should I wait until dry weather is coming?
Good questions. So you're not supposed to apply stuff along with the, and I just had a question, should I apply phosphonates? And Carol's done a lot of work with boron and urea to improve steps. And since then, along with Carol, did a bunch of work with and without boron and ureas, along with the gib, and they didn't seem to see any impact. So when you're starting at micronutrients, I don't know what's going to happen there. Avocados don't take micronutrients very well through the can. It's best applied through the root system, through the irrigation system. So if you've got a problem with zinc, that's a major one that we apply. I would do it as a fertigation through the irrigation. You really can't get very much into a tree as a foliar. So I wouldn't do it just and I wouldn't do it with gib because mess up the gib. So I'm saying I don't know. it's not registered for to have a micronutrient applied.
The next one. So is this GA3 under permit in order to prevent off-target issues, or are there human health and residue considerations?
No, it's because it was special local needs. It was fast-tracked. I understood the question, does it have an environmental effect? And is that why it's under an SLN? And it's under an SLN because that was the fastest way to get it permitted for grower use. It will eventually get a full registration. Is that clear?
Okay, so another question, am I correct? Is temperature must be above 50 degrees for 48 hours to ensure pollination and fertilization?
To ensure pollen tube growth to achieve fertilization. So it's once the pollen is on the tip of the pistil, it takes 3 hours for that to grow down through the pistil to the ovule. That's where you need to have 50 degrees.
Okay, how does production look for the year after the GA3 is applied? Does it hurt the tree at all?
No, that's why Carol took 6 years to do the study. It found no reduction in yield at the rates that she was using, and it didn't see a yield increase in every year that was used. But when you average it over the 6-year period, there was a clear increase. That was the 22,000 per tree per year. So.
Okay, the next one, does the rain affect the application? We are in bloom right now and would like to apply, but we have been getting rain.
Yeah, good question. The material is applied and is absorbed by the flower pretty rapidly. So, you know, 4 hours, 8 hours, when it rains, yeah, it'll work. You don't need, it's, remember you're applying it at 25 grams in a 75-gallon material, so it dries pretty fast and it's pretty fast. It'll wash off.
Okay, so we'll try this next one. Is there a less than optimum high temperature for fruit set?
Is there less, I mean, cold, can it be too cold for fruit set? Is that the question?
It just says, is there a less than optimum high temperature for fruit set?
Well, can it be too hot for fruit set? Well, definitely 118 degrees is too hot. You know, that's when flowers completely melt. The avocado grows best at about 75 to 85 degrees. So, you know, in that range, it's, you know, you're going to get good fruit set. I don't know that, you know, kind of would be for pollen new growth. You know, one of the problems of growing avocados in the desert in South America is that it is not for fruit set. We can flower in Palm Springs, which is fruit set. And so it's whatever it is, it's not Palm Springs. You have to provide shade and cool. But I don't know the maximum temperature. It's certainly going to be 100 degrees. Is it 90 degrees? I don't know.
Okay, so I've got the phone on now.
Okay, so we'll try it this way. Okay, so can you explain the mode of action that results in the increase in fruit size and what happens on a cellular level after the application at 50% flowering?
No. I was trying to emphasize that we really don't know how this hormone works. We know that it does work, but remember, Ga3 has multiple effects. It has impacts on cell division, cell elongation. It breaks dormancy in seeds. You know, is it accelerating the pollen tube growth? Is that how it's doing it, so that it, you know, it can reach the ovule faster? I don't know, and I asked Carol that, and she said she didn't know either. So I don't know. How's that for an answer?
Okay, that's, we'll go to the next. What was meant when you said needed wetting agent? Was that something other than the gallons of water?
Correct. The wetting agent is the silwet, the organosilicone material, and that improves the. Remember, you're putting on just a small amount of material, and if you look at a drop of water, it beads up. And so what you want this material to do is spread out over the flower evenly and to get into the tissue. That's why that question about, you know, do you have to worry about rain? Well, you don't want to apply it while it's raining, but, you know, it spreads out and is absorbed by the plant pretty rapidly. So what the wetting agent does is it helps it spread out and be absorbed. And that's, you know, one of the questions was, do you add a wetting agent? And yes, ideally you do.
Okay, so how soon is it rain fast?
Certainly within 24 hours. if you've seen a helicopter application on a normal day, and again, this is not going to work when it's cold. When it's cold and miserable, nothing works. So you put it on a normal day, when it's, early in the morning, when you're flying, it's absorbed by the leaf. When you go out a couple hours later, you won't see any moisture. It's been sucked up.
How much time is required before rain?
Before rain, as soon as it's dried out, it's in the plant. So a couple hours.
Okay.
You're not applying this to runoff. Yeah, you're not applying it to runoff. You're applying it at 75 gallons to 250 gallons by ground, and once the leaf and flower are dry, it's been absorbed.
Okay, I'm not sure of this one. Okay, how long from cauliflower extension stage 2 to open flower stage 5? It is really moving fast this year, but remains cold at night.
Yeah, so this is where you're making your best judgment. So it's not going to open. It's not going to work when the flowers are not at all open or at all close to being open. And I was out in an orchard 2 weeks ago, and the bottom part of the orchard was in full bloom. The top of the orchard was not even. There was nothing on the trees. So how do you decide that? I don't know if you can do half an orchard legally, but you've got to make these judgment calls, and it's better to apply it when you've got most of the flowers at least at the cauliflower stage. It's a hard call to make. Yeah.
Is the wetting agent of organosilicone material considered a surfactant?
Correct. It's a surfactant. Yes.
Okay, the next one, does coverage need to be on the flower itself, or does the Ga3 translocate through the plant?
It works through the flower. It does not work through the leaf. It's working through the flower. It has some effect on what is happening in the flower. That's why it's so critical that you're hitting this cauliflower stage. If it were, working through the leaf, then it would be, being translocated through the leaf. And no, it's something that's happening right there in the flower.
Okay. In addition to fruit set, do you see any other potential use for Ga3 and avocados, for example, young tree growth?
It does increase the amount of leaves. So that was one of the things that was noted. So, I would, the best thing to increase leaf growth is to water and fertilize. That's how you get the most, growth out of a plant. Ga3 is icing on the cake. When everything is right, Ga3 works. And if you want to get the tree right, you water it and irrigate it right, or water it and fertilize it right. So I wouldn't mess around with Ga3 trying to get more leaves on a tree.
Does it need to be cycled so that trees do not build a tolerance to it?
As far as I know, there's no such thing as a tolerance to hormones.
Okay. Have any trials been done on a second application directly onto the fruit when the fruit is still in the rapid benediction stage?
That's work that needs to be done. So if you can bring Carol back from retirement, she'll do it. But right now, we just have to find somebody to do that kind of work. There's a lot of work that can be done here, and the groundwork's been done now. Fooling around with concentrations and timing and stuff like that. There's somebody could make a career out of this at this point.
Okay, just a couple more. Have you any experience with using Ga3 to inhibit flowering in young trees?
To inhibit flowering, no. I don't know how that would be used because it's not normally used as a stop flower. A lot of times they'll use one of the abscisic acid materials.
Okay, and then just this final one is if you have any recommendations on readings to gain a better understanding of PGRs.
Oh man, online there's just so much stuff. But just, you know, if you just look at the major groups, ethylene, auxin, cytokinins, gibberellic acid, and abscisic acid, it's fascinating stuff. I really hadn't appreciated the effect of ethylene on fruit until we had those fires. And you'd see cherimoyas quarter of a mile away from the fire, but where the smoke had been, a week after all the fruit dropped on the ground. Same thing with sapotes. So smoke is full of ethylene along with a bunch of other things. So we're surrounded by hormones. So there's a lot of good reading. So I don't know of any textbooks specifically.
Okay, that was the last question. I hope I haven't missed any in the chat.
Okay, well, is that the end of the day?
Yeah, I think so. We don't seem to have any other questions coming in. So I think, yeah, I thank you for participating. And I think we'll be closing this out in just a minute or two. So thank you all for your patience, and we hope you will come back to our next one, which will be again on April 8th with Beth Grafton Cardwell speaking about citricola scale.